Okay, so it's short on details on what you need to. It's clear what you need to do once you look at it. We'll go through it step by step. So this is, and I'm recording the lecture now, um, so that you have that step by step, because we've got to talk about. So you've been given two files, a lab '05 grid class and a drawing tools. And we'll literally go look in here. I'm like, basically, this is what we've gone as lab '05 grid, drawable grid. The other file is drawing tools. And basically, drawing tools has a bunch of methods which have been defined, which you are going to complete. The one thing that I've done, I have used an alias. I've used rect to refer to a rectangle. And I'm doing this because I don't want to go and use the entire drawing package, because then you get there's things in Unity and things in the drawing package that there's similar name things, so you get ambiguity between the two packages. So to solve this problem, I've just gone ahead, like, the only thing we want to use is the rectangle. And I'm surprised Unity doesn't have a basic this rectangle class in their packages. So we're going in there using the rectangle class out of the drawing tools. Pretty straightforward. In this case, basically, the reason is that we need to be able to draw rectangles. Why? This is a box is basically your one of your basic collision detection pieces. So the goal here is that we want to be able to draw, like, if we have an image and we have a box around that image that we define to be the collision area, we want to be able to draw that box. That's the whole purpose of that. And that's going to make, as we move on, doing collision detection will make it much easier, because you'll see things are colliding or things are not colliding. So let's go through, basically, let's look at the rectangle structure. So in this case, it basically here's a draw rectangle. It takes it, so the first one is that in this function is there's a drawable grid, we call it grid. So again, one of the first things we'll do is, we'll deal with that one moment. But the goal here is that we have a box. And basically there is, what is the bottom of the box? This is like size, but basically it is X, Y, width, and height and width are the ones you're going to be playing the most. Other variables, but these are the ones that are most relevant. Let me just go bring up. So, where's my lines? I'm looking for brushes. There we go, marker. There we go, nice. All right, so I'll make these big points so that you can see. So again, obviously, this point right here is going to be the X and Y. So over here, this is going to be X plus with Y. X plus Y plus height. And this is X plus width. Y plus that a little bit more. I think we got these backwards. Because I do have this backwards. It's actually down here. My apologies. I did this backwards.
That's fine.
So basically, this is again. I got the so this is definitely x plus width. So this is the so the origin is going to be down here for the rectangle, and that's because of how Unity is set up. Going up basically up the screen is going to be our height. So these are the points that you are concerned about, and that gives us again x y plus height x plus width. So literally we can go in. So the big thing. So that's the big. So the box dot x, box dot y, box dot width, box dot height. So these are our variables that we're going to be playing with. I'm just gonna wrap this into a comment section right here. But the idea here is that the big thing is that I've given you the box. You've got the information. The thing is, are we drawing with the grid or are we not drawing with the grid? If we're not, so again, the first thing is if box is equal to null, is in screen space. And that's literally, we can go let's see, I'm gonna go grab and I'm blanking, excuse me. There we go. I want to grab. So we'll actually just grab the glint command. So it'll be I need to go grab bog X. What am I doing wrong? Oh, okay.
I'll be back.
Okay. What's Jacob doing? Okay, so essentially this is, again, you'll go through and basically go through and use the glint command. And I'm going to do one line just to show. But otherwise, else... you'll literally go grid, draw a line. Again, and then you'll build your new line here instead. So, I mean, we could in theory, let's do a line, bottom equal to new. Let's actually grab this. Oh, I forgot to. There we go. Okay. And so that we could then just put in. So this will actually make it simpler. So we're not doing the same calculations again. Here's x, and we can do plus box dot width. I'll just put this in its own parentheses just to clarify that. So here is one part of that box. Again, this is the draw rectangle. Again, the idea here is that we're either going to the glint command or we're using the grid draw line to do what we want. And that's pretty much straightforward. Again, demonstrate the box on the screen. All right, let's go back to the grid. So I've set up a rectangle here at 100, 100 by 100. Basically, we're going to literally go to what we do is drawing tools, draw a rectangle. What is the box? The box is going to be, we call it box. Color, we'll do color dot red. And we're going to pass this, because this is the grid that we want to be working with. So, actually, I'm going to start with the box. Actually, let me grab... And we'll make this 2 by 2. Okay, so the idea here is that I'm going to draw this 100 by 100 on the screen. I'm just going to grab this one more time. Box on grid. I'll make this green. And ideally, I probably may have, again, these are structures, so I could get away with doing this. If they were classes, I'd be building and set up scenes. But so basically, I'm just going to draw. Again, we'll see two lines because I haven't filled out the entire box. Let's go back to Unity. I have, again, one of the things you'll want to do is basically bake a Lab 5 scene. want taking grid. So I'll press play. Okay, so this is not. Okay, set up the scenes. Clear that out. It's an object. Why is this acting this weird? Oh, this is. Oh, scene manager. There we go. What is going on? Oh, let me just turn that off. Okay, now it's an instance of an object. Do I need to make it public? Do I need class static? Come on. What is drawing rectangle? What is what's going on? System. Drawing tools, draw rectangle system. Oh, it's in the drawing tools. What's drawing tools? Oh, wait a second. We want to. Yeah, what's going on? Not instance object. Drawing tools. 33. But what's going on? Okay, so one thing I think I need to do. Let's go back. Let's just grab the. Where's the NCTC? I think I actually have to have a. Okay, good. And then let's make these 10 by 10. Let's go back and let's now. What's going on? Oh, I'm doing box is equal to null. I need to do if grid is equal to null. My apologies. There we go. I used the wrong variable. Okay, so here we go. We've got basically the 100 by, this is the 100 by 100 pixels down here. You can see the green line up here. We can go to the scene manager. We start drawing the grid. There you go, drawing the axis only. So here is 100 by 100 in screen space. Basically 2 by 3, 10 units down. So here is so basically the idea here is basically fill out the, and I'm only drawing one line of the box. The idea is that you want to fill out the entire box. Draw on the grid and off the grid. Okay. Now we sort that out. The other thing is make sure that basically create an empty scene. I'll call this drawing tools test. So as you go on, you will be adding more variables here that you'll set up down here. But basically, for the most part, up until the very end, you will be at basically. Actually, I should. Let me grab these. Because basically later on you will then create circle object, create ellipse object. So we'll use this. So I'll comment this out for one moment. All right, let's go back to the drawing tools. I don't need drawable object. Great. There we go. Okay, so circle radius point. So the idea is that you are given a position on the screen. A lot of the time, this is going to be 0, 0. You're going to be given a float in an angle, and then a radius. And the idea is that you're going to find a point. So let's start. We'll start with. What did I just do? There we go. So it's going to be a vector 3. So start with vector 3.0, and this will be our result. So while I've got the stub code here, I'm going to just. So basically, the answer is pretty straightforward. Is so for the x, result is gonna dot x is gonna be equal to the mathf dot cosine and the angle in radians. So this is going to be angle times mathf degree to radians times the radius. So when you're dealing with the cosine, you're dealing with the x value on the circle. Pretty straightforward. It is going to be result dot y is going to be the sine, lowercase y here, and pretty much result plus equals the origin. So translate it back to where the origin is. And that's pretty much what you'll need for the circle radius point. Let me see. Let's go back. And let's create a so we'll create 2 lines. The first line is going to be circle radius line. We are also going to need and again, I'll just so we know we have it already. We'll be doing the ellipse. We will need a float offset. So we're just going to go in and say offset is equal to 0. And on tick, the first thing that we're going to do is basically offset plus equals time dot delta time. All right, we're going to use this to basically change the degree. So basically, each tick, we're basically gonna generate a new point. So basically, we're gonna go from 0, 0 to some radius. So we'll do float circle and we'll say 10. For a ellipse, it's going to be a vector 2. We'll come back to this in one moment. And this is going to be the ellipse axis equal to, I'll just do new vector 2, 10, 20. We'll be drawing these on the grid, so these lines will be drawn on the grid. So basically, they'll translate out. Let's create these lines.
Sorry.
Can you? And I'm going to use I'll use cyan. and I'll use magenta. There you go. All right. One thing I'm going to do with the offset, I'm going to use offset times 2 on the circle, so it rotates around faster. All right. Pretty much straightforward. We have just basically draw a line. And then what I need to do is now I need to go basically take circle radius. Oh, there we go. Why is it? I'll come back to this one moment. So it's going to be our drawing tools, circle radius point. Origin is basically going to be vector 3.0. So we're basically saying that, hey, we're drawing the angle is going to be the offset times 2. And then finally, the radius is basically the circle radius value. And by doing that, we can then go back to Unity. Actually, I need to draw the line. Where is... No. Why is it not drawing?
I don't think it was saved.
Oh, thank you. That would do it. So that's actually slow. So I'm going to go in, I'm going to multiply that by 180, just so we get a better feeling. So there we go. So there is now that working across time. And as we can zoom in, you can see. All right. The ellipse. So so the equation for a circle is x squared plus y squared is equal to some value. When you deal with an ellipse, the equation, let me see if I can pull that up quickly. Okay. When you have an ellipse at the origin 0, 0, the equation is basically x squared over a squared plus y squared over b squared. And when you do the ellipse calculations, basically the a and b basically are they're scalar. So an ellipse is basically a circle that's been scaled. Let's start by copying. Literally, we can copy this. Yeah, we can copy this and drop that down in here. instead of having a radius, you have the axis. So this would be x times the axis times x dot y. So that's pretty much the change. Rather than multiplying by a singular value, you have an x and y value. So, and again, we then translate this to the origin. And that's you know, these are going to be our workhorse pieces as we go forward. So let's get back into the code just quickly on the grid on this side. It's going to be the ellipse radius line in this case. And we're going to basically not circle radius, but and this is going to be circle, so ellipse radius point. So again, we're keeping it at 0, offset, and this I'm going to do 90 degrees every second. Actually, I'll cut this down, 90 and 45. And with that in play, we can now see that the magenta line is, you know, you can see it's diverging. Now we're seeing the ellipse, you know, by a line. The next thing is we're going to draw the circle. So we're actually, so that's the next thing that we're going to do. We're going to draw circles to draw the ellipse. With this method in play, it's going to make it easier just to draw. So the thing with what we're going to do is basically we're going to set a number of sides to the circle, number of sides to the ellipse. The minimum number that you have to have in order to make this work is 3. Anything less, then it doesn't make sense. You know, you don't have a circle. You have you basically have 2 points on the circle. So that's not a circle. That's just a flat line. So anything less than 3, I think let me stop this right now. And I'm going to pull these out to move these out much further so you can get these out of the way. But basically, we go back to the drawing tools. I actually say, if sides less than 3, default to 12. Yeah, that's just to have something there to make sense. So literally the first thing that we really do need to do is it's int number of sides is equal to sides number of sides is less than 3. Number of sides is equal to 12. There you go. And I'm going to do a compact style because this is basically to make sure, you know, default. And I'm really going to grab this line, these lines of code, because it's the same thing for the ellipse. I'm just going to drop that down in here as well. So this is just to verify we have enough number of sides. So the idea here is basically is that we're going to have a for loop for int I is equal to 0. If I is less than the number of sides, then we do I plus plus. The other thing that we need to do is we need to do a degree step. And it's going to be 360. You know, that's the number of degrees, and number of degrees divided by numbers of sides. Basically, we're going to do I times this degree step to figure out where we're at. Literally, we're just basically going to go. So basically, so the idea here is that we need a. I'm just going to do a vector 3. You know, I'm just going to use start and end. So basically, we're trying to figure out the side. So basically, we need the start of the side, end of the side. Literally, we're going to go in and basically start is going to be equal to drawing tool. Actually, we don't need to use the drawing tools because we're here, but it's going to be the circle radius point. We're going to pass position. The angle is going to be the degree step times I. And the radius, so we'll just pass the radius in this case.
Hold on. This theoretically be used to make a triangle.
You could, if the sides are number 3, yes, it'd be a triangle.
Okay.
That's like the smallest, like in theory, yes, you could make a circle with 3 points. A cylinder with three sides, essentially, if we're doing 3D. But then basically, this is what's going on here. We are literally going to take all of this, and end is going to be I plus 1. So we're going to go, so if we have, let me go back to paint. Where's paint? There we go. So ultimately I've got, where's my brushes? So here's 1, 2, 3, 4. Technically these, well, actually these should be, let me undo that. This is actually 0. Let me do the correct order. 1, 2, 3, and this will also be 4. So when I is 0, it's going to do 0 and 1. I is 1, it's going to do 1 and 2. I is 2, 2 and 3. I is 3, 3 and 4 completes the circle. And that will, any number, if I do 5, it's going to basically, again, we're making sure that we are coming up to the last, there are four points. We'll make sure they're going to I. So this will be, making sure that we're only going around the circle. By doing I plus 1, it will go from 3 to 4. Again, since 4 is number of sides, we should get 360. There might be, you may want to be careful. There could be there shouldn't be any funny business. Like that should calculate right back. But there's always floating point errors. So it might be 3.999999999, which for our purposes is the same as 4. So just be mindful that there might be a little bit, may not be perfect. If this is a matter for you, I mean that's a matter of making sure that it's an if statement in there if you want to make that perfect. We don't need to, unless it's causing an error. Unless you're seeing something, then don't worry about it. And we'll comment that here, like, hey, might get some voting point. So, hey, might get some floating point squirrely stuff because it's not perfect. So now we know what this, basically, so now that we have that, now draw circle is positioned to, this is a position to draw in screen space. So I want to be very clear that we're not dealing with the grid at all. So that will allow us basically to go, the other thing that we need to do is a line, actually, no, we need to create a new line. Do line, new line. But new line is equal to new line inside start and color. And I capitalized them. So there we go. And so now that we've got that, we've built the new line. Again, we can go back to the grid. Again, add command. New line. So let's go back and see what was the. So let's jump back to the grid. We can do now. Drawing tools. Draw circle. Position is going to be the origin. Circle radius, the value that we've been using. Sides, I'm going to do 36 just to start off. I do color dot, I'll do white. And with that, we can go back to Unity now. That is correct, except I'm not taking account in the grid size. So it will be circle radius times grid size. So this is we have to account. Jump back in. And now you can see that we've now got the circle. And the we can zoom in on that, and we can see that the blue, the cyan line is going around that as should be. All right, let's jump back to our code. So draw circles pretty, I mean, basically, the next functions are pretty much all variants on this. So in the case of, I'm just going to grab all of this right now. I mean, the ellipse, rather than start, if not circle radius point, it's going to be ellipse. And this is a case, it's not the radius, it's going to be the axis that we throw in here. So pretty much same, good, same thing, just slight changes. There's going to be, again, slight changes to the code. We can go in. Again, we can go back. Drawing tools dot draw ellipse. So in this case, it's going to be the origin again. This is going to be, where is the ellipse axis? Sides, I'll do 36 again. I'll do 12 just to show you what's going on. And then we're going to do, what would be, I use gray just so we have something different. The other thing I'm going to go in up here is I'm going to grab the and I'm going to do 40 and do 75. I'll do 50 and 75 just so that we have something bigger than the circle. And again, ellipse axis needs to be multiplied by grid size. Again, just make sure, just so remember. We go back and you can see right now there is the ellipse. Zoom out, you can see that. And you can see that, it is correct for 12 sides. I'm doing much more great, my, the radius line for the ellipse, you can see that it's going beyond the line. And that's because, again, we're doing an approximation of the circle. Like how many sides? I mean, we could do this better. I can multiply this by 36, or I can multiply this by, I'm doing 12 sides. I can get 36. I could get, 72 sides. There will always be a little bit of error between, because we're trying to build lines to the surface. I mean, like literally, I could go, maybe I go 360, and so every degree. But like on the half degree, there would be a slight error as well. And this is, again, don't freak out about this. This is well, to be expected. Let's put this in perspective. What you're seeing, the difference between again, if we go down even smaller, let me make the ellipse even smaller in terms of size. I'll do. Yeah, I'll do 3 for the heck of it. It'll be a triangle. And you really start seeing, technically, that is an ellipse of side of 3. And you can see all the error that's happening. But it is at this point correct. At this point correct. At this point correct. They are overlapping. But this is, again, this concept in science is like this comes down to what is the length of a coastline. You can measure the coastline, measure it again, and it can go. You can go literally infinite on a coastline because you're dealing with a curve. You can keep getting a longer coastline based on based on curves, and that's. Welcome to what makes calculus calculus. that calculus is a lot of what about a good portion of calculus is about like what is the error underneath a curve, and it's dealing with those type of questions. So that's reaching into like, hey, if you wanted to know why calculus is the way it is, this is because this is the questions it's dealing with. All right. So we're now just drawing things on the grid. And right now we're using the origin. I mean, I could move these. I mean, I could and I'm using the origin because it's convenient. But I mean, I could have. Let me go back. Let's bring down the size just a little bit. Yeah, I'll do 30 and 45. We'll do a. Let me see. It would be a vector 3. Vector 3. I'll deal with that. Vector 3. I'll call it draw test point. And so basically we'll say the draw test point is equal to the origin, and then draw test point. God, I can't spell today. X is, we'll multiply that by 0.5. There we go. So rather than using the origin down below here, I gotta figure out where. This is a good place. So rather than being on the origin here, so basically what I'm doing is I'm going to drop in draw test point here, draw test point here. Rather than 0, I need to go and screen to grid. Draw test point. So hey, first time we've actually had a use for the screen to grid conversion, and this will. If everything we've done everything correct in previous assignments, we'll know that. Yeah. So we didn't really test this function. We tested the other function. We did grid to screen, but we never tested screen to grid. So yeah. So we'll know pretty quickly whether we got that right in the previous assignment. And whether I need to go back and make a piece in that assignment to test that. But let's just jump. Okay, so okay, I know what's going on. They are drawing the hold on, I gotta go back and I know what I need to do. So what I need to do is circle radius line dot start is equal to that ellipse Okay, so I need to set start points to because right now, I need to set them to right now they're set to 0, 0, still to the origin, so I gotta set those correctly. And there you go. Now I've got that correct. Let's go back and let's at least bring this to 12 so it looks more like an ellipse. And so basically, you can see, basically, I've just shoved all those objects over to. So what's going? One of the things that's going on here is that with hold on a sec. With the just trying to think what's going with draw line, I am drawing with the grid. And with the draw ellipse function, because it's a line, I mean, I could have done this, but the ellipse radius point doesn't care whether you are on the grid or if you are on the grid or you're in screen space. It's just calculating based on these values you give it to it. It's going to spit out information. It's going to work whether you're in screen space or you are in screen space or you are in grid space. It doesn't care. It doesn't care which space you're in. It's just here's the equation, spits out the information. Kyle, you had a question.
Could you do it after images? Like,
What was that?
After images, like making it look like more like light than just a simple line.
That's not what we have.
It's just
It is possible. It is in theory possible. It is not implemented with the tools that we're given right now. Basically, this is simple line drawing tools.
I know, but I just want.
Oh, all right. We need to move on because that's not relevant to what we're talking about right now. All right. All right. So let's go back to the drawing tools. So I'm going to grab what's inside here for draw a circle. And basically, we're going to build, create, it is, same thing. It is position, radius, sides, color. Create position, radius, side. So it's the same thing. The big thing here is that, basically, I'm going to grab the code. I'm going to drop it in here. And the big thing changes here is that we're creating a new drawable object. Rather than glint add command, it is literally going to be new circle, add line to object. Again, the code for these come together really quickly. Like once you got we got the circle radius point function going, we were able to get the ellipse up and going pretty quickly. We used them to build the circle, to draw the circle. The ellipse was a small change. Now we're building drawable objects rather than drawing them directly to the screen. We're now basically building these building these into an object. And I'm literally going to go up and grab the draw ellipse code. Basically, I'm going to go through, draw, float. Okay, so I made a mistake. So with the drawing ellipse, this needs to be fixed. This is vector axis. So that's one change you're going to have to make to the drawing tools. I'll leave a note that there's an error there for right now, but that's a quick fix. And again, this is rather than new circle, it's new ellipse. And once we're done, you're going to return the new ellipse object. And this is an object again, and we can get. So this gives us, because now we're building them into drawable objects. So let's go up and actually. Let me see. So then we can go new object is equal to drawing tools. Create, again, it's create circle object. Position. So this is the position. So internally, what its position is going to be. Again, we're going to do vector 3 is at 0. Radius of, I'm going to use 10. Do 36 sides. Color. I'll use blue. And then we can go, I'm just gonna grab. Then we can add that right to the scene. And then we can do new object. Drawing tools, create ellipse object. We'll use vector 3, 0 again, because axis vector. There'll be a new vector 2. I'm gonna do 10 by 20. Sides I'll do 36 just to keep this smooth. And then I'll use color blue again. Capital key. Okay, so far so good. We can go in and go back to and we are drawing. Here we go. I turned off drawing the objects. So there you go. There they are. Okay, let's start having fun with this. I mean, they're drawing objects, so we can go in and basically say, hey, new object dot position dot y is equal 15. We can go and say your position dot x. So we can move them around. Oh, turn on drawing the objects. There we go. So they're now shifted. It just happens to be on there. Let me see. Drawing the grid, axis only. There we go. So you can see that I've got these going on. Let's have more fun with this. I mean, they're drawing objects. Let me turn on drawing objects, drawing the grid, and axis only, so we can. So this will help. We'll jump down into our tick. Oh, I need to. object. So before, so basically I'm going to stash that object reference so I can use it down below. And we can go, hey, new object dot rotation is equal to offset times 15. Or, yeah, we'll do 15. This is in setup scene, so that's not what I want. Here we go. So normally I wouldn't do offset by not, I wouldn't do like hard code those values. But for our purposes for testing, for showing things off, that's all that we need. But what ends up going to happen now that we've generated the ellipse, that's way too fast. Because I probably, I think we're storing it. Are we storing it as rate? I think it is math F degree. What's up with it? There we go. That's better. So that's 15 degrees. So again, what I needed to do is turn that to be, and I'm just going to go in, goes the box on the grid. I'll just drop this down to the other side so it's out of the way, so it doesn't look like it's part of that object. There you go. But yeah, here we go. I mean, like, this is that ellipse rotating. I mean, it shouldn't be too hard to build a box object. I didn't have you create a box object, but you could create a box object and you could have it rotate. So there's again, I've gone about hour and 15 minutes. I mean, the code, like once you get, I mean, the big things with is again the concept, the big concepts here that you need to get across is that we're dealing with points on a circle. All right. Once you get the radius point function working, everything else is just generic logic, putting it all together. Your two functions is the sine and cosine. Cosine always deals with the x value on a circle. Sine is going to deal with the y value on the circle. You provided a radius. You provide those functions in radians. It will give you a value on the unit circle. So for the circle, then you have to multiply that by the radius you want. That's at the center of the origin, and then you just add the origin, where the origin is functionally, the center of the circle is. For ellipse, the radius is replaced by an axis. So again, remember the equation of an ellipse is, again, the equation of a circle is x squared plus y squared is equal to some value. X squared plus y squared is equal to 1 if we were using the unit circle. Think of that underneath them is that there's a b. I mean, a circle is basically so the ellipse equation is x squared over a squared plus y squared over b squared is equal to 1. When a and b are equal to 1 or the same value, you have a circle. When a and b diverge, then you have an ellipse. And so functionally, again, the the equation of the ellipse is basically is whatever your cosine value is. The axis is basically just determining the radius of the ellipse on those two axes. So a square, so it's going to be a times the cosine of your angle converted radians, and then the y is going to basically going to be the b times the sine of your angle converted to radians. I mean, we're getting into cool territory right now. Like we're building tools. We keep building tools. Right now, I mean, at some point you're going to build, basically, I mean, we've got capability in here to build, little games, built based on, the old school, vector graphics. Our focus right now is in 2D, but 3D is not that far off. You're only a few steps away from implementing, perspective view in here. You've got the capability, and again, you've got the capability to draw lines. That's the lines of your object. .3D is just another translation. Points in 3D space, they have to be translated into the 2D space of your screen. And I want to keep, this is like the one thing that if you are going to take away from this class is that there are multiple types of spaces and there's different reasons for those spaces. Worlds, again, we've gone from grid space, which is essentially our world space, but it's a world space in 2D versus a world space in 3D. We've got world, and then eventually if we get there, there is, again, essentially when we start looking in 3D, we've got to translate our world space positions into screen space positions, and that's going to get, there's a lot more math. It just, again, this is why, this is the math physics course. So. Any questions? Yeah. All right. I will update the let me see. No, I'll just leave a comment about that one error in the drawing. No, I'll fix it. It's just it's a small error. Pretty straightforward. Again, as I showed you the process of doing this, it's pretty straightforward. All right, I'm going to stop the recording here and I'll upload it.